My name is Adam Oldfield. I work for SAISC Steel International and I'm a structural engineer. The ARB Warehouse is part of a distribution center, which is the central location for 36 branches for ARB Holdings. The facility has a large yard for cable storage, a 3,000 square meter office to hold the entire staff for the region, as well as a warehouse for all the electrical components. Because it's really a logistical warehouse for them, all their trucks, as well as a distribution center for the smaller vehicles, they required a column-free zone. So we used castellated members across the main warehouse and the yard, undercover yard area, and 2.2 meter deep girders to eliminate the columns and keep as much of the area a column-free zone as possible. I'd say the biggest challenge with specifically with the steel structure was actually the rigging process. Because of having a limited number of columns, it was actually the process of lifting the steel and the order in which we did that, getting the steel to site in the correct order as such in certain phases, and actually just how we braced the structure specifically in some of the windier months. And so I'd say rigging was probably one of the bigger challenges, and then also sheeting, just single length sheets, lifting them up to 18 meters I think at apex height, because there was a 50 meter canopy lean-to structure to lift the sheets over before we even got to the warehouse roof, so it was also a challenge. Well, the entire structure is made up of girders and castellated beams and columns, rafters and columns. So I think there's about 220 tons of castellated members there. So it was really just a space issue in terms of fabrication, and then delivery and rigging, as I say, just the process of phasing that. But just to get the timeline right, we're on quite a strict project timeline there. I don't think there's any other material that you could have built a structure like this with, you know, just based on in the warehouse area is 8,000 squares, there's only 3 internal columns, and there's only 3 columns across the 50 meter lean-to canopy where all the trucks load and offload. So in total, I think it's 7 or 8 columns in the moving areas. So just the versatility of steel allowed for that. I don't think there's any other way you could have built that. We use steel columns for, it's a lot quicker, we found, and also we've had issues in the past with getting concrete columns correct, specifically the connection details between concrete to steel, and this was a 16 meter high structure, so we just found that steel was the better option. What I'm most proud of is that we delivered the structure exactly to the client's initial brief on time. The entire project was finished within 8 months. That's from first spade in the ground to the client taking the office, which was ahead of schedule, and so I'd say that.